Today we will learn chapter 1 sets from the class 11th. First we will go for the introduction. So where these sets are introduction, where these sets are used. Okay, so the concept of set serves as a fundamental part of the present day mathematics. Today, this concept is being used in almost every branch of mathematics. In many of the branch of the mathematics, these sets are used. Sets are used to define the concepts of relations and functions also. After studying these sets, we can learn the relations and functions. Okay, at that time, these sets are plays an role very important. The study of geometry. What is that? The study of geometry, sequences, probability, etc. requires the knowledge of sets. To study these geometry, sequences, probability, we need the basic knowledge of these sets. Okay, and the theory of sets was developed by German mathematician. Who is that? German mathematician. Mathematician. His name is George Cantor. It is 1845 to 1918, and he worked on these sets when the problems on trigonometric series, when he was working on problems on trigonometric series. Okay, and in this chapter we discuss some basic definitions and operations involving the sets. Now the first question arises that what are sets? So sets means what? I can define a set. A set is a well-defined, well-defined, well-defined collection of distinct, distinct objects or elements. Objects or elements, both are same. So what is the definition of sets here? A set is a well-defined collection of distinct objects. Okay, so here well-defined word, what do you mean by this well-defined? Well-defined means collection of objects. We mean that there is a rule or rules by means of which it is possible to say without ambiguity whether a particular object belongs to the collection or not. What is that? Whether a particular object or element belongs to the collection or not. The objects in a set are distinct. There should not be a same elements in the given set. There should be distinct elements. Okay, so we do not repeat an object over and over again in a set. Correct, we should not repeat any. So each object belonging to a set is called the element. So I will give one example here. For example, sets are denoted by capital A, B, C, D, like A, B, N, Q, R, S. Any capital letters we are using to denote the sets. For example, A is equal to, this is a set 1, 3, 5, 7, 9. See here, these are all called elements. What we call object or elements we are calling. Elements or objects we are calling. So 1 is a element, 3 is a element, 5 is a element, 7 is a element, 9 is a element. So here the important thing is that here each element should be different, distinct. Okay, they should not be repeated here. Okay, so whether either if you take for example 1 is belongs to A or not? Yes, 1 is belongs to A. So these are all numbers. So instead of numbers it should not be any other thing, some names or capital cities or city name or flower name or river name or train name, aeroplane name, like that. It should not be different here. Here one flower and here it train name, or here boy or girl name, like that. It should not present. Well defined means what? These all the objects or element is going to belong for some object, for some thing, that is for example here numbers. So these are all elements or belongs to what? Numbers. Okay, so here each object belonging, these are all are called element or member of the element. Objects you can, or you can say that member also you can say. Okay, this is also correct. So sets are denoted, usually sets are usually denoted by by capital letters. By capital letters. What are the capital letters here? You can take A, B, N, Q, R, S, etc. All 26 alphabet, anyone you can take. Okay, and the elements which are present inside like this, they are denoted by lowercase letters. For example, lowercase means what? For example, lowercase elements or letters, you can say that elements are denoted like this: small a, b, c, x, etc. we are taking. Okay, the symbol, the important symbol, this symbol is nothing but belongs to. This will say that what is this? The symbol is belongs to. Okay, or you can say that or is an element of, is an element of, you can say. Okay, if we write some x is belongs to a, x is a belongs to a means x means any element here, 1 3 5 7 9. Belongs to a means this is the set a here. Okay, if I write like this implies what? X belongs to a. Okay, this is, you can read like this: x belongs to a. What it implies? X is an element of the set a. Okay, like this you can say. So suppose if I use this symbol like this, it is does not belongs to, or it indicates that does not belongs to, belong to, can say. Okay, or is not an element of, you can say like this. Okay, for example, if I say x is not belongs to a, it implies what? X is not an element of the set a, you can say like this, you can say. Okay, about belonging the elements of the given set and not belonging to the given set, that you got the idea. So you can conclude here, my dear students, like this: how here, given a set, some s is there, for example, and an object small p exactly one of the following statements should be true. So either first one is, either the p belongs to s means this small element object member of the set p belongs to this set s, or like this you can say small p does not belongs to s. Either this condition is satisfied or this condition is satisfied, any one will be true. For example, if I say ovals, set of ovals, for example, if I say take capital V is the set of ovals. Set of oval means a, e, I, o, u. So here a belongs to V. Suppose if I take k, k does not belongs to V, so k is not present in this set. Okay, so here all alphabet are there, and that to be vowels. So it is well defined. Okay, well defined means compulsory, it should be in a such a way that the given elements or member of that set should be belonging to some particular thing, like that ovals, flowers, like that it should be there. Okay, next is methods of describing a set. Okay, there are two methods very importantly. First one is a roster method, or this can be written as listing method, or this can be said that tabulation method. Okay, the second one is very important thing, set builder method. What is that? Set builder method, or you can say that property method, or you can say that a rule method. Some rule will be applicable here, by name itself it says. Okay, now the for some examples we will say here, some examples we will take. Odd natural numbers less than 10, some set example we will take an example. So a is equal to some 1 3 5 7 9. So this is the set. Okay, of A, this is the set A which is well defined. Odd numbers less than 10. What is that? Odd number, or odd numbers, I mean odd natural numbers. Odd natural numbers less than 10. Okay, so any examples you can take? The set of rivers of India, the vowels in English alphabet you can say, various kinds of triangles you can say, that is the set. Prime factors of 210 you can say, the solution of some quadratic equation you can say. Like that, many of the examples you can give. So first one we will go through here, a roster method. Which method it is? A roster method, or it can be say that can be known as listing method or tabulation. Roster method, first we will say what it means. A roster method means, in this method a set is described by listing all its elements, separating them by commas and enclosing them within braces. For example, you can take like this here. Example, what is that? A is equal to, you can take same example, this one, 1 comma 3 comma 5 comma 7 comma 9. Okay, here a set is denoted by capital letter A, and it is enclosed in the braces like this, and each element is separated by the commas. So once again I will repeat, in this roster method a set is described by listing all its elements, separating them by commas like this. Okay, so one more example also you can take like this. So you can take here, for example, B. So F O L W you can take the word follow, this word. From this word, these are the letters. You should not take double O, because here it should not be repeat. Okay, same element should not be repeated here in the roster method. So like this, many examples you can take. You can take any other example also. Which one you can take? You can take capital C here, set of integers like this and so on, -3, -2, -1, 0, 1, 2, 3 and so on. So here this set is denoted by capital C, and here it is in the braces like this, and each element is separated by the comma you can say. So in the roster method you can write like this. In this method a set is, so you can define like this, a set is described by listing all its elements, separating them by commas and enclosing them within braces. Like that you can define, and you can give a lot of examples here. Now second one is set builder method. What is this set builder method, or you can say property method or rule method? By name itself says property or rule, so there will be some rule or property. Okay, listing the elements of a set is sometimes difficult. Sometimes listing the elements, set of the integers, set of natural numbers, there are so many numbers, natural numbers, so it is difficult to note down all the elements or member of the natural numbers. Okay, so sometimes it is impossible also, it is difficult also, sometimes it is impossible also. So we do not have a roster form of the set Q. You can take Q is a rational number, so you cannot write the set of natural rational numbers here, you can't write. And similarly R also set of real numbers, this also you cannot write. All the elements of real numbers you cannot write, all the elements of rational numbers you cannot write. So sometimes it is difficult, and sometimes it is impossible to write in the roster form, which we studied previous one, roster form. Okay, so there in set builder method a set is described by means of some property which is shared by all the elements of the set. Okay, I mean that all the elements of a set, here you can say like this, all the elements of a set possesses a single property or single common property, you can say single common property which is not possessed by any element outside the set. Okay, for example, in the set like this, see here A, E, I, O, U. This is the set of vowels. So all the elements possess a common property here, namely each of them is a vowel in the English alphabet, and no other letters possess in this property. Denoting this set by V, we can write like this. Suppose if I say like this, V is equal to A, E, I, O, U, some common property is possessing here. Okay, so you can say like this, V is equal to some element X, such that X, all the X means all the elements, X is a vowel in English alphabet. You can say like this. Okay, so see here, this property X is a vowel in English alphabet. It is processing for all the elements. No other element you can't write except this 5 member A, E, I, O, U. You can't write any other English alphabet, right? So it is possessing here common one property or some rule it is possessing. Okay, like that you can write down. Okay, so or any other example also you can take here, any other example. So I will write, if P is the set of all prime numbers, then you can write P is a set X such that X is a prime number. So in roster form we were writing how we were writing P. What is the least prime number here? 2. Next one is 3, 5, next 7, 11, 13, and so on you are writing. So but it is difficult to write all the prime numbers here. Okay, so you can say that X is such that X is a prime number. So how many prime numbers you can to write? Below 50, below 100, below 500, below 1000. Okay, like that you can go. So any other example also you can take. So in the roster form you can have a set of natural numbers, but here also you can say some A which is equal to X such that X belongs to what? N, natural number. Okay, that is what here you can take. Okay, it is closed bracket, but it is difficult to write in roster form. Suppose A is equal to, you can write here natural number 1, 2, 3, 4, 5, and so on. It is very difficult in this one. This is roster form. Okay, so from roster form, the set builder form, you can write like this. Here also it is roster form. Okay, so from here also you can write, instead of writing all the elements by commas and you can separate, so you can write here by set builder method or property method or rule method by very easily. Okay, so like that some numbers I will tell here, some basic thing I will tell. Please remember, these are all very important. If it is there n, sometimes we denote by n like this also. Okay, so this is set of natural numbers. Okay, so you can take Z also. Z means what? Integers. Okay, Z, or you can take I also. Okay, like this. These are the standard notations. Okay, Q also you can write like this. Okay, this is Q like this. Okay, so it will be a set of rational numbers. Here R, if you take here, it is set of, you can write like this also for all the set of real numbers. Okay, if you take Z plus positive, the set of positive integers it is. Okay, you can take Q plus also. Q plus means what? The set of positive rational numbers. Can have R plus also. R plus means what? The set of positive real numbers. Okay, these all you should remember. Okay, natural number, integer, rational numbers, real numbers, positive integers, positive rational numbers, positive real numbers. These are all very important. Okay, thank you.